It's time for another Best Class in School activity. Today, we'll use Google Earth to help us navigate our entire planet and also learn many different and important characteristics that are sure to help us in the future. Here we have Earth.
Wow.
As you can see, this is a clean image of Earth without any clutter, such as names of places, atmosphere, pictures, etc. This is accomplished by simply turning off everything in the View menu of your Google Earth. Having this clear image of Earth to start off with will help you understand better this lesson. First, let's travel a bit. First thing we'll get to see is the North Pole, followed by the South Pole. You can clearly see just how much bigger the South Pole is.
Wow.
These two are the coldest regions of our Earth simply because they are the regions that receive the least amount of sunlight throughout the year. We have here the Atlantic Ocean and also the Pacific Ocean.
Wow!
Imagine just how big the Pacific Ocean really is. It almost covers half of Earth. We now turn to the two largest countries in the world, Russia and Canada. Here, there is also a huge difference in size, as you can clearly observe. Well, that's just to show you that normally, the biggest or largest of something on Earth is truly unimaginably big. We'll now focus on the western side of Earth, the place we call home. But why is it that we are on the west? How do we know this? Well, that's easy. Let's turn on our grid lines of Google Earth to understand this better. These are imaginary lines created by man in order to be able to organize every place on Earth and give it a specific location according to a system called the coordinate system.
Wow!
This system is made up of many vertical and horizontal lines, and each line corresponds to a different number. The first important line we'll consider is the equator line. This line divides Earth into north and south. So as you can see, Guatemala is in the north, while countries such as Colombia, Brazil, and Ecuador have parts of their country on the north and part on the south. But what about the east and west division? Well, for that, we'll need to travel to Greenwich, England. Let's now turn on our Find feature in Google Earth. You'll find it under the Edit menu. Let's type in Greenwich and fly over. I will now back out in order to see the big picture. So this yellow vertical line you see here is called the prime meridian. This line divides Earth into east and west. So anything to the left of your screen, beginning from the prime meridian, is on the western hemisphere. And everything on the right of your screen, beginning from the prime meridian, is on the eastern hemisphere. This is how we know where we are exactly on Earth. Now, let's go back to our side of the world, also known as the West. Let's now turn our focus to these two other horizontal lines that run parallel to the equator. The one on the north is called the Tropic of Cancer, and the one on the south is called the Tropic of Capricorn. They help us identify the places on Earth that have a tropical weather system just like ours. The big difference is that anything you see here in between the tropics is practically a two-stage weather system. It's either summer or winter, not much in between. While the zones outside of the tropics, such as the US, Canada on the north, and Argentina, Chile, and Uruguay on the south, have a four-stage weather system. These regions have summer, winter, fall, and autumn. Now let's get a little closer to begin observing certain important details. You can now notice that the lines are beginning to show both numbers and letters. The letters are easy. N means north, the S stands for south, the E for east, and W for west. So at the intersection of two lines, you'll automatically know what hemisphere you are right now. Take for instance Peru. We can see that the horizontal lines are showing me a W and the vertical lines are showing me an S. That means we are in the southwest part of the world, also known as the southern western hemisphere. As far as numbers go, that shouldn't be that complicated either. They are just numbers that show a degree sign next to it. But if you get closer, you'll notice that more and more numbers are coming into the picture. Why is that? Well, let me explain. Between each number on either latitude or longitude lines, the distance is 69 miles, which equals about 111 kilometers. Of course, having that point of reference is still way too big if you wanted to point to an exact position on Earth. Let me give you an example of what I'm talking about. Let's say that you were traveling by ship from Japan to the US. Then you would have to travel through the Pacific. Clear enough. But let's say that your ship runs into trouble and it just stops working around this point of the Pacific Ocean. You have radio communication, but how exactly do you tell the people on the other side of the radio where they can find you? Would you just say, "I'm in the Pacific, please come get me"? That would be just too much ground for anyone to try and cover, and actually being able to rescue you. That's where our coordinate system comes into play. You would need to tell the person your location by providing your coordinates. This would give a precise point of where they would be able to find you and rescue you. It's actually the only way you would ever get rescued. So, back to the point at hand. The first thing in a coordinate will always be a letter. It will be either N, S, W, or E, followed by the degrees number. Then comes another number, and this number will be called minutes. Yes, I said minutes. And yes, you might have guessed it already. Between each degree, there are 60 minutes. That means 60 lines in between each degree line. Here, you can see exactly what I mean. The closer you get to Earth, the more lines that come into play.
Wow.
And if you go closer now, a third number will make its way to the coordinate system, and this number will be called seconds. And once again, as you might have figured this, there are 60 seconds in between each minute line. So this provides enough information for you to be able to identify a specific spot anywhere on Earth by providing your coordinates. By the way, when I mean provide your coordinates, I'm talking about a set of 2 in total. It would not be enough to provide a single coordinate number because that wouldn't help at all. Let's say that you're lost in the Pacific Ocean and you only provide the west coordinates, but not the north coordinates. Then they would still not be able to find you. You need to provide both numbers so that the intersection between both coordinates provide the exact point of where you are.
The best class in school.